In this video, we're going to use MechMat to determine the combined loading stresses on a circular cross-section. For this problem, we're going to select Circular Cross-Section and then click Select Case, Circular, Non-Circular. Now our problem involves this bar here that's attached to a brick wall. Now its dimensions are 12 inches in the Z direction, 6 inches in the minus Y direction, and then 3 inches in the minus X direction. At the end of the pipe, at 30 degrees from the Z-axis, we have a 500-pound force pulling at the end of the pipe. The cross-section is shown as such. It has a 1-inch outer radius and a 0.875-inch inner radius. Now we can decompose that 500-pound force into a 433-pound force in the Z direction and a 250-pound force in the minus X direction. Now in order to enter these into MechMat, we need to find the R and F vectors, which is simply the vectors comprised of the components of the distance from the cut to the application of forces, the R vector, and the F vector, which is just the vector of the force. So these are shown here. The R vector is minus 3i minus 6j and plus 12k. The F vector is minus 250i, 0j, and 433k. We're going to start by taking a look at shear in the X direction. We have our main window followed by two new windows that will show up at this point. We have the stresses box in the bottom left that keeps track of the answers as we progress through the problem, and the help box in the bottom right that tells us information on the various variables that come up throughout the course of the solution. So for instance, we have T, and that is the thickness at axis CD, and it also lets us know that Q and I are calculated about the axis CD. As you probably notice, we aren't actually calculating any of the section properties for this because that is done for us via the program, and we'll get to that in just a second. So the first place we're going to look at is the components of moment at cut. Now the program has calculated all the various moments at the cross section, and we're just going to simply select FX Shear and hit Analyze. Now we're going to use the section properties that it has calculated for us in the rest of the problem, and after having hit Analyze, the box in the top right will appear, and it asks for shear due to FX, which is the neutral axis, and it also asks for where there's zero stress. Now, once you've input your answers, and for this it'll be CD is the neutral axis, and there'll be zero stress at A and B, we'll hit check, it'll tell us correct, and then it'll open up the box just below that, which asks for the magnitude of stress. So, as you can see, we've entered in 676.923 psi, which is the correct answer, and hit check. And then once you've done this, the stresses box in the bottom left will update to reflect that. At this point, you can now select FY Shear, FZ Axial, or any of the other aspects of this problem to continue on from here. Now before we go to look at shear in the Y direction, we're going to take a look at a utility you have at your disposal should you need it. Now if at any time you are having trouble remembering what equations to use to calculate the stresses, you can always click the Help button that was on the main window. If you do so, it brings up this screen, which shows you all the different equations you need to calculate the various stresses. So for instance, it has the equation for calculating bending stress, has an equation for calculating shear stress, shows you how to find the area for a circular cross-section to determine the axial stress, and also has the equation for determining torsional stress. We're now going to take a look at the shear in the Y direction. So once again, our main window, we are going to select FY Shear and click Analyze, which opens up the box as shown in the top right, as well as brings up the Help window in the bottom right. This time the Help window says that T is the thickness at axis AB, and we're calculating Q and I about axis AB. Now, in the box in the main window to the top right, it's now asking for shear due to Fy, which is the neutral axis, and where there is zero stress. For this, we're going to select CD for the neutral axis and zero stress at AB and press check. Now this is the correct answer, and at this point we'll enter in the magnitude of the stress calculated from this. Now since Fy is 0, the calculated magnitude of the stress will be 0. So that is shown here, once again, our stresses box has been updated to reflect that. Next, we're going to take a look at axial stress in the z direction. So for this, it's a very simple calculation. It's just force over area. So our force in the z direction is 433 pounds, and our area, based on the calculations from the program, is 7.363 e to the minus 1 inches squared. And when we take that force divided by that area, we get the correct answer, which is 588 psi. Now this is entered into the stresses box and saved for later evaluation. Now that we've determined the shear stresses and the axial stress, we're going to now determine bending stress about the x-axis, y-axis, and finally torsional stress. So we're going to start with bending stress about the x-axis. As you can see here, we have selected MX bending and have clicked Analyze, which brought up the box to the top right. We also answered the question, for bending due to MX, what is the neutral axis and where is there zero stress? So for this it'll be AB is the neutral axis and there will be zero stress at A and B. We've hit check and we got the correct message, which brought up the box just below it, which asks for the magnitude of stress. Now our help box also tells us that D is the distance of C or D from axis AB, and that I is calculated about axis AB. This will be used to determine the magnitude of the stress. Now once we've calculated that, we can enter that in and press check, and a amount of 7,994 psi is the correct amount of stress due to bending, and our stresses box has now been updated with that information. Now that we determined the bending stress about the x-axis, we're going to look at the bending stress about the y-axis. So we've selected my bending, we've pressed Analyze, we've answered the question, for bending due to my, what is the neutral axis? That will be CD, and there will be zero stress at C and D. We've pressed check, and we've also entered in the magnitude of the stress, which is 5,233 psi. We press the check button, which, as before, updates our stresses box with the answers. Now the last thing we're going to look at is torsion about the z-axis. So we're going to select MZ torsion and hit Analyze, and then it'll simply ask you for the magnitude of stress. So once you enter that and hit check, and in this case it's 2,307 psi, it'll say correct, and enter in this final answer into our stresses box. Now that we've found all the answers to each individual section of the problem, we can review all the sections via the stresses box. So here's our stresses box, and it includes the shear stress in the x direction, the bending stress about the x-axis, the axial stress in the z direction, the shear stress in the y direction, the bending stress about the y-axis, and the torsional stress about the z-axis. Now you can solve circular cross-section problems of your own using MechMat.